Okay, I think we're live. Hi, Dr. Oates. How are you?
Hey, I'm good, Portia. How are you?
Good, thanks. All right, so we'll give everyone a few minutes here, or not minutes, rather, just maybe some seconds to log in and get settled. While we're doing that, I'm going to make sure everyone's aware of a few logistical things about this webcast. So this webcast is being recorded. It will be available on our Bright Talk channel and on our website at a landing page, which is linked in the attachments. I will talk about that again at the end, but that landing page also has a form for people who are in particular interested in this research project that Tim's going to talk about here in a minute. And it also has a link to the blog that we posted last week and some other things. So that's one logistical item. The second is that there is a presentation that you can download to follow along. For those of you who don't know Tim, Dr. Oates is a professor, so we're going to let him do what he does best in a virtual setting and lecture. But you can follow along if you download the presentation. Again, it's available in the attachments. It's the second attachment. So I will assume that most people have logged in by now. Thank you for joining us. So you know you are in the right place. We are here to talk about the research that Synaptiq's AI team and data scientists have been doing on public COVID-19 data. So this is obviously really important topic from the perspective of just the public. I know I'm personally interested in it. I'm working from home without help right now and trying to take care of a kid. So I'd love for this to get resolved. And I know that there's different problems that require different solutions. And so what we're trying to do, just to be clear, here at Synaptiq is volunteer our time to look at the data problem. There's a lot of data. So Tim's going to talk more about that. But just so you know what to expect in this webinar, we're going to have a brief introduction to the team. And then Tim's going to talk a bit more about our research project, how it originated, what we're doing and why this is important, not just today, why this work isn't just important with respect to COVID-19, but also in general, maybe being more prepared next time and applying this to other similar problems. Tim's going to give a little kind of AI 101 for those of us who are not supremely technical, but I know that he'll make it valuable and relevant for those of you who are. I know there's a lot of researchers on here that come from the medical space, so I think this should kind of help align you to our processes and how we did what we did and our methodologies. And then at the heart of this presentation, we're going to do a demo and look at some of the findings from our initial research. And finally, we'll wrap up with some real-world applications so that you all understand kind of how our methodologies apply in different areas. In particular, right now, I think it's important to look at how critical industries can benefit from some of these. I know a lot of our clients and partners have been talking a lot about that since the pandemic. And so we think it's important to mention. And finally, we'll talk about what's next, what you can expect from our team, what we're working on. And again, for those of you who are just joining, we are going to keep you informed. We've got a landing page which you can link to from the attachments in the Bright Talk attachments section of this webcast. There's a form in there that will specifically indicate your interest if you have something that you want to mention in the message box, ideas, or if you are a medical researcher or an epidemiologist, you want to get in touch with us, you can tell us all that stuff on that form there. So, and I guess finally I should mention at the end, we'll do a question and answer session. So if you do have questions, I encourage you all to pop them into the question chat. We'll get to those at the end. So without further ado, I'd like to introduce first our speaker, and then I'll mention the backgrounds of some of our researchers. As you may have noticed if you downloaded this, the attachment to this presentation, we changed the name to 6 data scientists dive into COVID-19 research. When we originated this, there were 4, now there are 6. I think it'll grow a little more, which is exciting. So leading the charge is our presenter and our star for this webcast, Dr. Tim Oates. Tim is a professor of computer science and electrical engineering department at the University of Maryland, Baltimore County. He has his PhD in computer science from UMass Amherst and spent a year as a postdoc at the MIT AI lab before coming to UMBC. He's a co-founder of Synaptiq, along with Steven Scaluru, our CEO, and has experience consulting in a diverse set of industries. We will have a guest presenter that was not initially advertised when we sent out notifications about this webinar. Akshay Peshav is an entrepreneur. He's a self-described divergent thinker. He's going to join us here for the demo halfway through our presentation. Akshay focuses on knowledge-based systems that automate knowledge acquisition and reasoning and representation. He has a startup project called Keratin, which you'll probably get a sneak peek at in a little bit. And his previous work at other startups include Teller, a Bay Area fintech company. Just quickly on some of our other researchers, we've got Hugh John, who has a decade of experience developing and building software models for light-based sensors and cameras. So he's done a lot of our work on machine vision for this project. He's received his PhD and his Master's of Science in Electrical Engineering from University of Maryland, Baltimore County. Saurav Mukherjee has extensive industry experience. He's also working on this project. He's worked with Microsoft and Amazon in the past, and he also has his PhD and Master's in Computer Science from University of Maryland, Baltimore County. There's a theme here. Let's see, Keontae has extensive industry experience as well, mostly in data analytics and programming, machine and reinforcement learning. So that gives you an idea what he's been helping us work on. He's in his third year of computer science PhD at University of Maryland. And finally, but not least in any way, is Ashwin, who is a research scientist and a PhD candidate specializing in artificial intelligence. I'm going to end that introduction there because I could go on and on about this incredible team, but that is not why you all joined us. So I will let Tim take over here, and I'm going to turn my camera off and mute myself so that you can focus on what Tim has to say. I hope you enjoy it. Thank you so much, Tim.
Yeah, thanks, Portia. All right, and thanks to everyone for joining. I think I'm going to do 4 things today. One is I just want to start out by kind of level setting. What is it we're doing and why are we doing it? We're not making any grand claims about having any sort of novel insights into coronavirus. What we're really trying to do is get our heads wrapped around the data, and we'll talk about that process. So first, level set. The second thing then is to do a really quick sort of AI machine learning 101 kind of thing. Maybe we'll do the entire thing in 3 or 4 minutes. Then what we'll do is we'll demo a couple of technologies. We'll bring Akshay back in at that point. He's done some really interesting work with the research papers that are publicly available on coronaviruses and a few COVID papers. And then we'll just kind of wrap up and talk about some ways in which the same kind of machine learning technologies can be applied in a lot of different industries to kind of broaden the scope of what we've been talking about. So, why are we doing this? We're doing it because there's this pandemic, which I think about a lot. I think everybody thinks about quite a bit of the day. And then there's a lot of data that's popping up around it. So lots of people want to help. The scientific community is getting very engaged. There are many publicly available data sets that are out there. And we would like decisions to be made on a scientific basis. So part of what happens, though, is that there gets to be this decision-making paralysis. And I see that even in just my daily life, as I get so much information. Is it safe for me to get takeout food or not? How do I deal with the takeout food when I bring it home? Just this morning, my middle daughter is not feeling well. She's got swollen glands, and so now do I take her to the doctor? What do we do? So there's so much information out there. The question is, how do we make rational, informed decisions? So, and healthcare workers are facing exactly the same problem. There is currently a ton of COVID-19 data in terms of research studies. So there have been 153 COVID-19 research studies published in under 4 months. That's twice as many SARS studies that were published in the first year. And the Lancet group is receiving 30 to 40 submissions a day. So we've got a link to the source for those statistics in the presentation. So again, there's this flood of data coming out, and the question is, how do we make sense of it as individuals? And then is there any way that we can help healthcare professionals or people who are making decisions at a higher level do their jobs better? So, why are we doing this as a company? Everybody wants to do something to help. I see that as being a pretty common theme. Just as a company, we know data, we deal with data a lot, and there's a lot of it on COVID. So really what we're trying to do right now in the context of this project and then moving forward is just to be better informed about the underlying data. We're just getting in and trying to dig around in there. So often when I talk to companies about consulting projects, sometimes they get a little paralyzed in the sense that, oh, there's so much we could do. We've got so much data, and they have a hard time committing to anything. And, we always say, oh, we'll just jump in and do something. And so that's what we're trying to do. We're just trying to jump in, get our hands around some of the data, try a few technologies out, look and see what works, and then try and educate ourselves as we go. So what's there? What's the quality of the data? How can it be used? What are some interesting things that we can do that might be informative? And, at minimum, we'll sort of know more about the underlying data and what it says about the current pandemic, maybe help those around us make better decisions or point them to information that might be useful to them. And then moving forward, we'll see if we can do something that's sort of interesting and novel. There are lots of groups around the planet that are doing that right now. So for this particular project, we look primarily at published research papers. And actually, we'll talk about, there's a data set out there that has COVID plus some other sort of SARS and MERS related papers that have been published in the past. We've also looked at some social media, Twitter in particular, to start trying to connect those things up. And then we've played around a little bit with video and images. They're not, you'll see that the machine vision stuff that we've done is kind of tangentially related to COVID. There are data sets out there of, say, lung x-rays, and you're trying to determine whether someone has COVID or not. We're not going down that path. We've got just kind of a demo. There are lots of other kinds of data out there, many forms of it. There's time series data. So, we've all looked at new cases by day plots. There's geographic data. So we're actually starting to gather some tweets by region, and you can kind of start matching those things up with cases by region. There's also relational or sort of graph-based data. So some of these papers are actually, there's metadata which says how are these papers linked by talking about shared concepts or citations and things like that. So what I want to do then is, So just again, the idea is sometime in March, we said, hey, this could be interesting. It's now early April. We're just sort of in the process of trying to get our heads wrapped around the data and understand what's there and what the possibilities are. So the next thing I want to do is just do this really fast, like sort of 5-minute long, machine learning AI 101 kind of thing. For people who are in need of a definition, I like the one that was written by Tom Mitchell, whose machine learning textbook I used to use a lot when I teach machine learning. He basically says, paraphrasing, machine learning is the study of how computer programs can get better at some task with experience. And so these days, experience usually means I got a big boatload of data sitting out somewhere, and I'm going to use that to drive machine learning. And the tasks can be quite varied. So there are systems that learn to play the board game Go. You can learn to optimize your marketing spend. You can find blemishes in manufactured products using machine vision. So there are lots and lots of ways in which machine learning can be applicable. A lot of use cases that we see have to do with companies who are trying to improve efficiencies across the organization. So interestingly enough, some of it is I've got data, so my manufacturing process seems like it's broken a little bit, and I need to identify when I have problems in products. But a lot of it is my organization needs to run more smoothly in some way, and there are ways that machine learning can help you identify ways to make that happen. So in this project, where you're going to use machine learning to look at more effective searches of collections of research papers in ways that I think are kind of interesting. We're currently looking at ways of exploiting the relationships among those papers in terms of entities that are mentioned about conditions or procedures. And we're doing just like a little bit of machine vision to kind of play around with it. So in machine learning, and again, very high level, there's sort of 3 types. You'll hear people talk about supervised learning. And I think about that as having a collection of things and then labels associated with them. So think about, you got emails in your inbox, and they're either spam or they're not spam. So a thing is an email. The label is it spam or not spam? Related to COVID, it could be, here's a lung x-ray. The person either does or does not have COVID, for example. So in that case, you're trying to learn from those examples that have been given you to take a new thing, like a new email, and say whether it's spam or not. In unsupervised learning, you just get things, you don't get labels. And so maybe I've just got a bunch of emails, and I want to sort them into groups, and maybe I'm doing that based on, topics or things like that. And then there's this whole other area of reinforcement learning, which is essentially, how do I learn to take actions in a world? So if I exist in some environment, I can look around and see what the state of the world is. I have a bunch of actions I can take. How do I learn to take action so that I get maximum rewards in the future? Where reward is, you can think of it as just a number that says you're in a good state, you're in a bad state. Turns out reinforcement learning was used recently to learn to play the game Go at world-class levels. So another important technology, we're not going to talk about that too much today. So that level of thinking about machine learning is, kind of what are the algorithms, or what are the kinds of things I can do? I can do supervised learning. I can do unsupervised learning. I can do reinforcement learning. Another way to think about it is sort of what kinds of tasks are you looking at? So one of the tasks that we're thinking about is natural language processing. So, humans in general we communicate by natural language. Is the easiest way for us to do it. A lot of our knowledge is encoded in text and recordings and things like that. So people are great at accessing the content, the meaning behind that. Machines have a harder time with it, but we're actually getting better at it as a community. And it's even the case that a very common situation that we find is a company comes to us and says, hey, I got this PDF document that was created by a human. I'd like to kind of extract out the knowledge that they used when they were creating that document. So we see a lot of that going on. So typical kinds of tasks there include information extraction. So can I look at a document, for example, and pull out the name of the individual in a form? There's also text classification. Should this document go to human resources or should it go to some other department? Question answering, where I have a question and a big collection of text, and I like to find answers to that question in the text. And we'll see something that's not question answering, but sort of more like retrieval based on questions. There's also natural language entailment. If I tell you a few sentences, can you tell me what might be, what could you infer from the content that I've given you? And document similarity, and it goes on and on. So they're really great tools for doing those things. The state of the art is quite nice in the sense that it's very easy to grab some data and start forging ahead on that. So machine vision is another area, and this has seen a real renaissance lately. So people are really good at understanding images and videos, right? So I don't know, like a 3-year-old child, a 2-year-old child can see a picture of a cat and go cat, and it can be, a variety of kinds of things. It can be a cartoon, an actual cat, it could be a video. And machines are getting really good at doing those kinds of things these days. So they're good at finding objects in video, sort of, finding all the people. And we'll see an example of that a little bit later. Image classification. So again, this idea of, can I take radiology images and tell you whether you have a tumor or some other condition? There are machine learning systems that can do as well as trained radiologists in that case. And that's a perfect use case for machine learning systems, where we might have lots and lots of labeled data, where radiologists have labeled data, but they are the individuals are highly trained, relatively rare. Their time is very expensive. And so if you can get a machine to do the same task at a fraction of the cost, then that's a great thing. So, okay, machine vision. And then finally, we do a lot of just what I would call data science. And, data science kind of plays in the same space as machine learning. But when I think about data science, I think about, how do I get the data from point A to point B? How do I load the data into a database so that it's easily accessible? What kind of pre-processing do I do so that the data is in a format that is suitable for ingesting by some of the machine learning algorithms? So in many cases, you spend the majority of your time doing that kind of work, just because often data is sitting in weird places. And then actually there's this point, which is domain expertise is super important. So judicious use of domain knowledge can make the task for a machine learning system much easier by letting it be more accurate with much less data in many cases. Now, in this case for COVID, we're not domain experts at all. We're not even pretending to be, so that's a limiting factor. But again, part of what we're trying to accomplish here is to try and do some learning and educate ourselves. So the next thing I like to do is actually, show some of the results and talk about some of the work that we've done, particularly with text. And so I'd like to bring Akshay back in. Akshay, are you there?
Yeah. Hey.
Hey. So do you want to take over, maybe share your screen and talk a little bit about what you've been doing and that we've been helping you with?
Sure. Hi, everyone. I'm glad everyone could join. Let me just quickly share my screen. All right. Can you see that, Tim?
I see it, yeah.
All right, great. So yeah, I'm just going to build upon whatever has been said about the number of publications being published. Right now, there's an open research data set available, part of which was published on Kaggle as a task challenge. And that has about 13,000 curated research publications. And if you go to Semantic Scholar, they've got over 36,000 research publications on coronavirus and anything related to COVID. Now, the catch there is, according to a Reuters study, 153 COVID publications were published and technical reports. So it's not just research publications, and they're not necessarily peer-reviewed. They may be under review. So 153 of them, and then there's an additional 30 to 40 a day that are being submitted for peer review. So out of the 36,000, there's only 153 that are directly related to COVID. Now, in this kind of setting, researchers need to somehow come up with parallels between research done on past coronaviruses and how that can be applicable to the current coronavirus. Just to explain how researchers are doing things right now when it comes to literature searching, here's a search query, which is a reasonable but slightly long search query that researchers might do. It is typically looking for information about incubation periods for MERS. So MERS has been researched over the past few years. And then there are some other, underlying niches like age groups and health status and how contagious is this stuff. Currently, the systems available, like Elsevier and Neural COVIDx, they have been unable to present any results given this search query. Then there are some specialized search engines, if you want to call them that have been coming up. One is the NLP group from University of Waterloo. There's Synaptiq, COVIDseer out of UPenn, or Penn State, I think, and Vespa. So if you go from left to right, you realize that you're going from no results to the more niche NLP kind of search systems that are giving really small result sets. Like in these two cases, it's 20, and they're not really high precision. What I mean by that is the top results are not necessarily relevant. And then there's COVIDseer and Vespa that are giving more than 10,000, and in Vespa's case, more than 43,000 results, search results, basically everything under the sun. Now, one way to look at it is, given this long query right here, many of the words that are not really the core theme of the search query, but are certain qualifications and nuances on top of the core theme of incubation periods for MERS, is wreaking havoc in most of these search engines. So what's the solution? So the way we're thinking about it in our research group is, what is needed is not just simple keyword search, but more of discovery. Now, how a researcher thinks about discovery or literature survey, which is a more technical term, is you come up with a seed list of some most relevant articles, right? Artifacts in this case could be research papers, white papers, or actual peer-reviewed publications. Once you have that seed list, then research groups start doing divergent discovery. They start expanding their exploration in terms of concepts with an overarching theme, and then steadily they try to converge through detailed reading, we call it deep dives, and converge upon certain gaps in research that can be addressed by their group. Now, when a search engine is working, the search engine requires certain keywords, and they're going to come up with results. That's how search engines work. But we feel that now is the time when search boxes are a portal or a window into a larger discovery landscape, which automates most of this discovery thinking that research groups do. And the way we are trying to achieve this aspect is through unsupervised theme detection, where we do not rely on global dictionaries out there, no predefined wiki terms or set of keywords or key phrases, but we leverage patterns within the document and within the corpus. These are patterns related to words, and then construct phrases. Don't rely simply on words, because keyword search relies on words for the most part, and then results are not as desired. So rely on concepts as phrases and create those phrases from patterns, not global dictionaries. And then we're going one step forward and trying to see if construction of a knowledge graph where we can connect literature to these concepts can actually help drive some of this discovery workflow, exploration of any kind. And the one aspect that we're investigating right now is, how do we connect concepts to each other, even though they don't occur in the same research publication, but related research publications. So we are trying to see co-occurrence within a research publication, and how does proximity kind of exhibit some kind of transitive relationship between themes across literature. Here's just an excerpt of a knowledge graph that we've been constructing using the COVID Open Research dataset. Here, what we're showing is on the left-hand side, you have a MERS, the core MERS concept, which is the MERS coronavirus. COV stands for coronavirus. And on the right-hand side, you have the SARS coronavirus. And the blue dots are all publications. The orange dots are all concepts. So here you can see that MERS and SARS are connected to each other using a whole bunch of bridge concepts. The associations between these bridge concepts and the core MERS and SARS concepts have come about through publications that discuss each other in two different contexts. Some SARS studies are citing MERS studies. Some MERS studies are talking about SARS and work done on RNA in SARS research. So this kind of, it looks like a tripartite graph because we've not populated it completely, but there's a whole bunch of publications that are related to the concepts in the middle. And these kinds of subgraphs can be leveraged to perform very informed discovery, which will augment traditional search engines. As an example, we take the search query that we ran on the other systems again, and we know that we're looking for incubation periods and MERS as two key concepts. The way we make the system understand that we're looking for the user's looking for incubation periods and MERS is by creating an index of unsupervised of concepts or themes learned in an unsupervised manner in a separate thematic index. And that thematic index tells the system that, okay, incubation periods and MERS is the overarching theme of the search query. And then you can go into the graph, the knowledge graph, and start.
Hey, Akshay, I think we lost you for a second.
Huh.
Tim, are you still there?
Yeah, I am. Did we lose Akshay?
We did.
Okay.
Do you maybe want to take over where he left off, or should we give him a second to try to get back in?
I don't know. Maybe do you want to?
Oh.
Did I see him pop up?
I think he's gonna. It looks like he dropped, so he's gonna refresh. If y'all don't mind holding for a minute for our technical difficulties, we apologize. We should get Akshay back here in a second.
Yeah, let's just give him a second to come back. I mean, I could continue on with a little bit of additional stuff while we wait. What do you think?
Yeah, I think relating it back to what you were talking about earlier, just drawing that connection would be really helpful.
Right. Okay. So again, I mean, I think this exercise is to try and help people who might have questions about the scientific literature related to coronaviruses and COVID-19 in particular, to be able to pose questions in a way that's natural, right? So I have a lot of stuff going on in the question that Akshay was showing, and I want to be able to get results out of that are focused and not too numerous, and point me to the information that I could read. So we're not trying to answer questions. It's not question answering. It is simply trying to surface information that's going to be most useful. Hey, Akshay, are you back?
Yeah, where did you guys lose me? Because I think I lost connectivity.
You were going through the example on what, slide 21?
Okay, hold on. Just let me know when I'm at that slide.
Yes, that one. Go back one more. Yep, it's the next one. Yep.
Okay.
Yep.
So yeah, as I was saying, so I'm revisiting the search query that was used to show the performance of other search engines, and just for the sake of being able to accommodate some kind of information on a slide, this is just a small little subgraph from the knowledge base that we have, and we have a thematic index, which is basically an index of unsupervised themes learned in an unsupervised manner over every document and then the whole corpus. And there's weights and whatnot going on, and the heuristics tell us tell the system basically that in this search query, incubation periods and MERS are the overarching themes, and everything is like an underarching nuanced concept. So in this graph, we've got 3 artifacts with MERS COV as the core concept, and you've got 2 concepts related to incubation. If I try to expand one of these, you get artifacts directly connected to this incubation-related concept, and you've got another incubation-related concept here. I believe this incubation-related concept is incubation period, and this one is incubation period by age. There's this, and then if I try to expand this concept, you get an artifact which directly discusses this incubation-related concept, and you've got certain nuanced concepts here. Now you've got infectious period, which is a period after the incubation period, and then there's the recovery period, and there's a latent period. So we can just keep expanding these out and capture more artifacts or research publications. So what is the end game, right, of all this research? One is, of course, the discovery interface, which lets COVID researchers discover research and concepts within the research, given the limitations of, or given the challenges, the 2 key challenges, which are over 36,000 publications, but only 153 right now directly related to COVID. But there is a chance, a high chance that research pathways followed for one particular coronavirus can be also followed to do research or conduct research for the current coronavirus, which is very closely related to SARS. So the old SARS virus is codenamed SARS-CoV-1, and the current one is codenamed SARS-CoV-2. And then the second aspect that we're exploring, and something that Dr. Oates touched upon when he was speaking early on, is public narratives. It could be Twitter data, it could be narratives by policymakers, or any kind of public commentary about the current situation. Can we connect them to published research or published literature of any sort? So there's 2 objectives to doing that. One is, can we propose additional information to readers or viewers of public narratives? And secondly, can we fact check any kind of social narrative that's being circulated? And a key example, which is pretty popular currently, is, does 5G spread coronavirus? Right. Completely nonsense, but it was trending on Twitter, right? So stuff like that, and so that's the end game. That's what we're trying to achieve.
Okay.
And all right, with that, I'll pass it back.
Okay, great. Thanks, Akshay. I appreciate it. So I realize we're running short on time, so I'm going to move relatively quickly through the rest of this. I just want to show one quick, simple demo. Oh, sorry. Now I'm sorry. This is the first time. Oh, so, okay. Maybe I'm not going to share my screen because it's wanting me to do some system-y stuff. So, okay.
You can share it. Is it the video of Times Square?
It is.
Let me see if I can do it, Tim.
Okay. Sorry about that.
No, cool. If you hear my coworker in the background here, one sec.
Right. Let me know when you, because I can't figure out. Okay, there you go. So, okay, so this is just a very simple demo that we put together. So, this is a video that was shot of Times Square actually very recently, and we're using very much off-the-shelf standard tools to do things like identifying vehicles and people. But then also when you're identifying people, you can do things like say, are they getting within a specific distance of one another? So you can see these links being drawn when people are not doing proper social distancing. I mean, the idea here is one, just to show that, again, these are tools we're using, I think Facebook's Detectron 2, some OpenCV. So very simple things that are publicly available. You can go and download and spin up something like this actually relatively easily. The interesting thing here is that a lot of the models for forecasting the spread of COVID have a lot to do with what has been put in place to try and prevent it. So, you know, different states, different municipalities are doing things differently, and the extent to which people adhere to the guidelines is going to impact the spread of the virus moving forward. So we were starting to think about ways in which video feeds might be used, and there are a lot of these things that are publicly available, to start looking at the extent to which different places are, you know, either more or less crowded. I saw some news over the weekend that there are a lot of popular tourist spots in China that had opened up and they're packed again. And so the question is, what's the impact of that going to be moving forward? So, okay, thank you, Portia. You can stop sharing now. So the last thing I wanted to do was just talk about some of these use cases. So the kinds of learning that we're talking about doing here have applications in lots of different industries. So financial services, food and agriculture, healthcare, government, technology. I just want to talk about a few use cases in maybe 3 minutes that we have seen that embodied some of these techniques. So in finance, we've actually done some work in looking at payment processing. So the idea there is a company had a big collection of information about their customers and the ones that were taking a little too long to pay. And so their accounts receivables was actually quite high. It's a very large company that had lots and lots and lots of small customers. So in that case, you can actually train a supervised model to identify customers that might be late on their invoices and then target those for the people in the company to be able to reach out to see if they had any questions. We've also done work on the natural language processing side, looking at patient intake in healthcare systems. So there was a client that had an extensive questionnaire that was asking patients questions at intake. And when I fill those things out, I get very bored very quickly and just start trying to get through them as quick as possible. They had that problem just all over the place. So we did some interesting data analysis about patient responses in the past, and then built a bot that asked questions in a much more natural way that seemed much more focused, and it allowed the company to differentiate on their product offerings. In the machine vision space, there's a lot of applications in transportation. So can I classify vehicles by make and model? So there are companies that supply, for example, information about vehicles that are moving around when there's an amber alert. Do I see that license plate? Do I see that plate on a car of the appropriate make and model, for example, to track vehicles? And then document processing is another interesting one where we are doing machine vision applications. So as I said before, a common use case is, hey, I've got this form that was filled out. I'd really like to get the information out of it. So a lot of it is document classification, which is something that we talked about before. That's a machine vision problem where here's a scan of a document. Is it Form A or is it Form B? You can also try and find specific fields in the document and then robustly extract the content. And a last kind of interesting one that I'll talk about is automated legal responses. So turns out there's a lot of times when law firms will send a letter off to the government and say, hey, we'd like to do the following thing for this client. And the government sends a letter back and goes, no, you can't do that. And here's why. So we've worked on systems which try and look at the forms that the government sends back, identify what their causes are, right? So we're doing information extraction to figure out why is the government denying this thing that we want to be able to do? And then connect rebuttals to the cause for the denial and fill in slots based on the information extraction. So a lot of this for lawyers tends to be kind of cut and paste. Oh, they're saying you can't do it because of X. We're going to respond Y, but we need to slot in specific information and then kind of compile that document and send it to a lawyer and say, okay, here's what we think the rebuttal should be. And the lawyer can go over and make a final check. So those are just some use cases. All I wanted to say about what we're doing next is, this is all still very obviously very early days. We're just trying to dig into the data a little bit. We're going to start trying to do a little bit more focused data. I do like this direction of saying, can we look at things that people are talking about in Twitter, for example, and then be able to surface sort of peer-reviewed, trustworthy information that people can read to inform themselves about the questions that they're having. So I think going down that path is going to be one that we all seem to find interesting. And it's just, going to take us a lot longer to kind of dig through the data because there is so much of it. Okay, so that's all I had to say. Portia, did you want to come back in and yep, maybe Akshay?
Yeah. Yep. All right. So thank you guys. That was really interesting. I want to make sure that we have a chance to answer some questions from the audience. I have a question, or maybe it's a point of clarification for Akshay, maybe two. First one is, in terms of what you demoed, I think, I believe I understand this properly, but I want to make it clear for people who are watching. The visualizations that you were sharing are related to actual, like an engine that works. It's not just theoretical, right? Could you just kind of clarify that for us?
Yes. So the thematic phrase detection is an engine which is part of Carotene stack, and it's a service that's available for automatically tagging documents. And in this case, it's actually crunching through all the publications and coming up with those themes. As for the graph part, the graph is being constructed as we speak. Actually, the code's running. It's not connected to the Carotene user interface as of now. Simply because that should be powering a discovery process, which is a human in the loop. It's not very automated, and we actually have a question related to something similar along the similar vein, and I'll address that in a bit. So yeah, that's the first question you had.
Yeah.
And that graph, so actually that graph that you showed, that's sort of an internal data structure, but that data structure can be leveraged in lots of ways to, as you said, kind of like expand nodes and explore more nuanced differences in the question that they're asking. Is that right?
Sure.
Yeah. Mm-hmm.
Yeah.
Okay, and then the second question, which I think is an important one from the perspective of researchers. So can the work on knowledge graphs enable researchers on COVID get hints from past coronavirus research in the absence of a lot of mature research on the current coronavirus, novel coronavirus COVID-19?
Yes, it can. So if you remember the example, once I expanded to 3 levels, at one point you get hints of incubation period not being a core phrase in research publications, a lot of research artifacts. But then there's I see latent period, and then you've got an infectious period, and then you've got a recovery period, right? So those are related nuances or related concepts, and researchers can, if you follow that entire exploration path, can actually come up with ways in which they can explore COVID, even though COVID-related research is not directly available. If you remember the big graph that I showed, that actually shows how SARS and MERS connected, how the research connected, where they were talking about a whole bunch of RNA-related studies and vaccinations and interventions and all of that. So researchers can gather hints from there.
Got it.
So
Okay.
I just wanted to jump up. There was one question about lists of open source machine learning tools.
Yeah, I was going to make sure you address that one, Tim.
Yeah, so the answer is yes. And there's so many open source machine learning tools these days that you kind of need to know a little bit more about what it is that you're trying to do. So a lot of what we use is a tool called scikit-learn, which is part of a growing Python ecosystem for doing machine learning. So scikit is a good place to start if you have pretty generic needs. It implements lots and lots of different machine learning algorithms and then infrastructure around them for running experiments and munging data.
And that's PSY, Papa Yankee Sierra, or Papa Sierra Yankee Psi.
No, it's SCI. And
SCI, okay.
I can't do the Alpha Bravo thing, so
okay.
SCIKIT.
And if someone wanted to, we do have real people answering the form submission. So if you fill out the form and you have a specific question, you put it in the message, we can respond, in some realistic time frame with a specific question about that.
And one last thing is, it's also the case that there are these GitHub lists of sort of papers and tools related to various topics. So you can always do, machine vision tools GitHub in Google, and that might find you something. But as Portia said, if you have specific needs, we can answer questions on that.
So here's a question that looks like probably both of you could answer this one. So a question that a lot of people are asking today is, will I have an asymptomatic or mild case? Can you search the literature to find the suspected causal factors for the severity of illness? Now, we're not doctors, so I just want to say that before you answer that question is a big caveat there. But what do you guys think about that?
I think it's actually a question.
Yeah. I'll quickly add, though, for the previous question about open access machine learning tools. For this particular domain, Semantic Scholar has compiled a pretty good list of stuff that you can use for natural language processing. It's called SciSpacey, and they've got an embeddings model, which is SciBERT, which will help anyone quickly ramp up with a little bit of know-how of basics of natural language processing to start processing text. And for this question, so the question is, will I have an asymptomatic or mild case? Now, if you enter this into a search box, even in Carotene search box, right, it's going to pick up the themes as asymptomatic and mild cases, or severity of cases. Yes, it's going to be a latent theme. But then your follow-up, which is, can you search for literature automatically to find suspected causal factors? Now, suspected causal factors will come up through the human-in-the-loop exploration. Because the whole idea of discovery is give you a seed list which is directly relevant to your original query, which is asymptomatic case. And then through human exploration and using the discovery user interface, you can actually reach the part where the related concept is causality and severity, right? Similar to me starting at incubation period and reaching latent period and longevity and stuff like that. So yeah.
Okay, and I know we're coming up on the end of the session, but I just want to say, well, we've got a few more questions. I think they're good. We're going to carry on with them if that's okay with our speakers. And just so there's only a few more here. So another question, I think this is probably just general. The question is general meaning for either Tim or Akshay. Have you worked with any genomic data?
So not in the context of this particular work for COVID in this project, but just as a researcher at UMBC, I have. I've done some collaboration with some people in the biology department, and I'd be happy to provide more details about that offline if you wanted to, just because we're short on time. And then there was a related question, sorry, Portia, just to jump ahead, is that, you know, somebody said, well, to the point about domain knowledge, yeah, I mean, if there are people out there that are, you know, medical researchers or microbiologists, and you want to be able to inject some of that domain knowledge, that would be super helpful, because it's hard. You know, I think Akshay does a really good job of sort of looking at the results and trying to interpret them. But we might believe things to be true about the results. They look good to us because we just don't know what we're talking about. And so collaborating with people who know the domain better would be great.
We have a form, again. I keep hammering this home, but we will respond. So if you do want to raise your hand for that, please fill out the form. It's available as a link from one of the attachments on this webcast. It's a landing page. It has this webinar on it. And if you scroll down, you will see a form, and it will ask what in particular you're interested in getting in touch with us for. And if you include any information in that message, that'll help us. But we would happily take hand raisers and volunteers that have domain expertise. So please do use that resource to get in touch with us.
And then sorry, just one more point.
Yes.
So somebody asked about the tools and algorithms that Akshay was demonstrating. So he mentioned SciSpacey. So Spacey is actually a really good open source tool for doing performing lots of tasks on natural language text, from parsing it to part of speech tagging, finding noun phrases, information extraction. And I think SciSpacey is a version of that where all the models have been trained up on scientific literature as opposed to whatever it was originally trained on. Is that right, Akshay?
Yeah, that's right.
Okay.
There's another question here. I think this is the last one. Do you have new bridge concepts? If you take the next steps from the bridge concepts of MERS and SARS, now bridge to COVID, could you address that question?
Yeah, sure. Also on the open source tools that were used, Neo4j is one more for the graphs. Open source community edition is available. If you want to productionize, you can go for an enterprise edition. If you're a startup, you get a pretty good setup of enterprise Neo4j for free from Neo4j. Okay, so comment to this question, new bridge concepts, bridging all of that to COVID. So COVID publications right now, as they're being published, whatever I showed you is based on the Kaggle data set, which had about 13,000 publications. And now we are trying to ramp up to the Semantic Scholar data set, which has the whole 36,000, and they keep adding publications every day. If latent concepts come up in COVID publications, let's say the 150 COVID publications, and we have connections from those concepts to old concepts that we derive from SARS, MERS, or any other publication, we can show that connection. And then it will start popping up in search results, even in both search results, right? The seed list, as well as this kind of concept stack that we're creating, where related concepts are shown as stacks, and then humans can actually interact with the user interface and keep exploring. But as of now, I don't have any bridge concepts to tell you. And again, speaking to what Dr. Oates said, right? I'll just echo that back. We're not domain experts. We're seeing data. I know that, okay, if the weight of an edge is 1 and another is 0.5, I know 1 is more possible than 0.5 because I see the numbers that way. But yeah, so no specific concepts as such.
The questions, there's one more question if you guys want to take it.
Mm-hmm.
How could we use the information to information retrieved from the project. You're working on, let's say, get specific control measures, country-based, ethnicity, ages, medical records, so forth, even though COVID-19 is a novel type of coronavirus.
Sorry, let me find the question.
It's a long one.
Specific control measures, country-based.
Okay, yeah.
Right. So is that asking about, right? So I think what you're asking about is, obviously, I mean, I think in the news yesterday, it was found that COVID seems to be hitting different ethnic communities harder than others. And so what you really might like to understand is how do the results apply to me personally or to a particular group that you're interested in. And so I think what we'd have to do is to dig a little bit deeper and do some information extraction out of the articles. So there are open source tools, again, where you can sort of train up a system to say, I'd like to find the ethnicities that are mentioned or ages or other factors that you might like to pull out. That can be a hard problem because sometimes there'll be, here's the results for men, here's the results for women, here's the aggregated result. And so, kind of connecting that information up can be a difficult task of piecing it together if you want to pull it out in numeric form. But you would essentially have to sort of peel the document open at a finer level of granularity than what we're currently doing. However, obviously, this tool is an important first step to find the relevant articles.
And then we got one more question. This is literally the last one, and I'm going to just answer this quickly. Someone asked about time series data. We did not do that in this first pass.
Yeah, that's right. I mean, I've done a lot of work with time series data in the past, and I thought about it, right? So it's real tempting to kind of look at those beautiful little bell curves and say, oh, I could learn a model that fits that thing. But actually, when you read about it a little bit, and it makes a lot of sense, there's an enormous amount of domain knowledge that goes into that. So, what is the density of the people in the area? What are the current measures that are in place? And if you hear is it the University of Washington that is putting these reports out, and they say, well, these estimates assume that people are, engaging in appropriate social distancing and other measures are in place. So that's an area where I think for this particular problem, just looking at the raw numbers is not going to be super effective. And you need a lot of background knowledge to be able to build models that are appropriate or that are accurate. And even the models that they're building have these giant error bars on them just because it's a real hard problem.
Well, I think that's a good plug for knowing what you don't know. I think that's one of the things this team is really great at doing and demonstrating. So again, I encourage people to get in touch with us. If you have additional questions or you want to send us data, you want to send us an idea, you want to raise your hand, please use the form on our landing page, which is in the attachment section of this talk, which I've said now several times, but it is very important to us because this project is very important to us, as it is all the work that people are doing to help bring this pandemic to a resolution. I want to thank our presenters. I realize I never remember to introduce myself. It's like, don't you know who I am? My name is Portia Roberts. Thank you so much for joining me today, Tim and Akshay. It was such a pleasure. I hope everyone found this informative and interesting. I know I have really enjoyed watching this project unfold, and I'm really looking forward to seeing what we've got next. I will commit to staying in touch with everybody who raises their hand about this. When we do follow up with information, with data sets, with Python notebooks when those are available, with a follow-up webinar, if we can get that together for you in a timely fashion and makes it relevant, I will make sure that you know about that, anything that we do down the line. So again, thank you so much for joining us today. I really appreciate it. I hope everyone stays safe and healthy, and we will be in touch.
Okay. Thanks.
Thank you.
Yep.
Bye.